Today we're going to see how to do remote unit testing on a Windows to Windows setup. So the main development machine is a Windows machine, and the remote machine is also a Windows machine of the same architecture. Usually in this kind of setup, the remote machine is an embedded constrained system such as a Raspberry Pi, and your main machine is a much powerful desktop such as a Linux or Windows. In this demo, we're going to try to do it in a Windows to Windows setup, and we're going to use Visual Studio 2019. So first, let us check the remote machine and what it looks like. So I have a remote desktop connection to that machine, and that machine looks like this. It has a user, Johnny, will be operating the remote machine as Johnny, and the remote machine has drive C and drive E. And the prerequisite here is that the main machine should be able to SSH into this target machine. And I already have running here the Windows built-in SSH server. So let me minimize this and let me go back to the main machine and let us try to SSH there without any password. So let us SSH as Johnny, and we have successfully connected without any password. Let's go back. So because the user here is DX, we're going to use drive E in order to simplify the path naming. So I'm going to go to my drive E and demo. And we're going to use this example project. It's a small C++ project, Visual Studio solution file. Let me launch it by opening Visual Studio and load the project. You will notice here this menu, Parasoft, because we installed the Parasoft tool as a plugin here. So we are going to do unit test, and we're going to execute the unit test remotely. So the principle that I'm going to show here also applies if you're going to do application monitoring. First, let us try to build the project, and we have successfully generated an executable. The application monitoring just executes this executable directly, so it will be according to the flow of the original program with code coverage as a result. But we're going to show here unit testing instead, but the principle is the same. First, let me do a local unit test by generating test cases. We have generated our test cases. First, let me try to run unit test locally. First, right click, run unit test. So in contrast to application monitoring, which use the original executable of the program to generate code coverage from, the unit test is creating a new executable containing the execution of the generated unit test. But again, the principle that I'm going to show here to do remote execution of this stuff into the remote machine is the same. We have executed locally the unit test, and we can see the coverage statistics of this execution, and we can also see highlighted colors of the coverage run. So all of this is local, but this is going to be the starting point to understand how to customize this local execution in order to instead do remote execution next. What's really happening under the hood is there is a CPP test hidden folder, and in this folder, the generated executable here, which is different from the actual program executable, is where the instrumented test cases is compiled to. So it is an executable containing a call to the generated unit test. And this is what is giving us the coverage report. So all of these are run locally. Now, our goal is to execute this remotely. So let me delete this run here and let us modify the custom workflow in order to achieve our goal. So we go to this menu here, this configuration. The local execution that we did a while ago is was using this configuration here, run unit test, right? But because these are the built-in uh, the test execution flow, we could not modify this. These are hard coded. In order to customize this flow, because we're going to execute our test remotely, not locally, we're going to create a duplicate of this flow, and you can see it here. Now we have a duplicate where we can modify. Okay, we can rename this like customized or remote run unit test. Okay, and in the execution tab, we can click this edit button and see the XML that was driving the execution. Now, you will need some time to take a look at the structure of this XML, but I will put a different uh, jest file of the structure. But to cut the story short, I already have this XML here, and the original XML looks like this. I just clean it up. I indented it with a correct tab to look more clearly. So a workflow is called the flow recipe template, and you can find additional documentation of this in the Parasoft forums. And then we can see that this set property and set property nodes contains key value pairs. So, for example, if you retrieve the value of top config file, it will be coming from the set value that we define here. And then we can see here that we have okay, this one, custom step. You can see that we executed the executable here, and then that executable generated the log file and the clog file. But maybe it's more clear if I'm going to run it manually. So let me cancel this. Okay, it's always more clear to see things as it happens. So these are the two important test artifacts that we need to generate: the CPP test results clog or a coverage log, and the CPP test results log or test log as deletes. But remember that these two files here is what generated the code coverage. It was deleted. Okay, now that they're deleted, let us execute this instrumented these cases again. Um, it's not obvious what's happening here, but if we are going to open a DOS prompt instead, and I will go to drive E, and run again the executable, and we can see this error dialog. CPPT's runtime 64 DLL was not found. Okay, this is a, a generic principle in Windows programming that we always need to have the DLL. So in order, because we're doing it manually, let us put that DLL side by side for now. But take note that all of this is automatically done when you're operating on the IDE, so there's no need to do that. But it is very instructive to understand what's happening under the hood. So the DLL can be found in two places because we are installing Parasoft C++ Test as a Visual Studio plugin. Important to copy the correct DLL accordingly. So first, the DLL is actually located in the installation of the Parasoft as a plugin. Let me find that. Let us find that in Drive C. So it's here. So I am emphasizing this because during the installation of Parasoft, if you're using the Eclipse IDE, you can also find the same DLL there, like here. And these two DLLs, although they have the same name, but they're different. So this one is a more specific DLL that works with Visual Studio because Parasoft tool is installed as a plugin, and this is what you are going to copy. However, if you're using the Eclipse IDE of Parasoft, then you'll be interested in this DLL. So we're using Visual Studio, so we're going to copy the associated runtime DLL for Visual Studio that was put there. So it as copy this, okay, we now have the DLL beside the exe, and if we run again the executable here in the DOS prompt, and it has executed without any problem. It is close this, and as a result of that execution, we can also see now the CPP test results log and test log generated. In fact, if we delete this again and then execute again, and you can see them reappearing. So this is the principle of operation here. So therefore, what needs to be done in a remote execution is to copy this exe and this DLL together over to the remote Windows PC, execute it there, and then it will generate these two output artifacts, copy back these output artifacts locally, and visualize the code coverage. You can do that manually, and if you're curious to improve your workflow, uh, you can do it as you wish, but we'll try to do it automatically using the IDE and the customized XML. Another thing that I need to emphasize is that this path here, eDemo, should be the same in the remote machine because it has memorized this path in the executable. So if we look into the remote machine, we can see that in drive E, it's still empty. Okay, let's go back here. So now our mind is now properly set on how to. I mean the changes that I'm going to show here will now make sense. Again, that is the principle. Execute this beside the DLL, and we generate these two artifacts. And we have to do that remotely. So let us go to the XML workflow that controls the local unit testing. So the local unit testing is defined by this workflow here. Since this is built in and we cannot modify this, I have duplicated this up here. So we have a duplicate of that here, and I rename it uh, a remote run unit test. So you just need to right click the built-in and then duplicate, and it will appear here. And you can now modify this rule to our purposes, which is we need to copy the XCNDL over to the remote machine, execute it there, and collect the covers log locally. So that's the plan. Go to the execution tab. Okay. If we click this edit here, we can see the XML workflow that was controlling the unit test execution. Now, take some time to understand the structure of the information structure and relationship of the XML. Usually, XML is very nice. I mean, it has a robust information representation in terms of these kinds of things. So take time to understand the flow of that. To look clearly to that XML, I open that up here in the IDE here. And okay, to look it more clearly, and I indented them properly. So this is the original XML of a local unit test. So it has a parent node of the root node of flow recipe template. You can find a detailed description of this in the Parasoft forums website. But the thing that I'm going to show here that will make sense now is in the custom step here, we can see that the XC is concatenated to the project name. So this is actually the demo Visual Studio Solution.exe. We executed this. It generated these two log file and this log and covers log. And once these two files are present in the hard drive, we invoke the run native test. I mean the read native test log. It will read this, and then read native covers log. It will read this, and then that is how the covers report is generated in the IDE, etc. So this has an implied top-down flow. Some of them are not exactly in that flow, but more or less they are top-down. So this thing is going to happen first, and then followed by next. So conceded. At least it looked like that to me. So how do we customize this workflow in order to execute this executable remotely? So by common sense, first we're gonna copy the executable and the DLL remotely. But before we can copy that, we have to create the folder structure first in the remote machine and copy the XCM DLL and execute it. And that is where the SSH service comes into play here. So let me switch to the other tab here. Okay, and this is the modified XML. So let me go back to the original. So they look the same except with a simple addition. So we added more properties and we added more custom workflow. Okay, so I will do this step by step. So these three stuff were not in the original XML. Let us add this. So let's go here and modify the workflow, edit, and then we only have two set property. Let me add, sorry, it's not, I press the enter key. Okay, control V. Okay, so we just pasted the three properties. Let me click the OK button, apply. And we can see that by adding those three properties alone, we can see now three GUI entries that we can modify from. So let's go back again to the XML and let us add the these three these customized steps. But to simplify for, let me just copy all of this and put it here. Okay, and then let me modify this IP address 192.168.2.241. Running. Apply, close. Now let us go back and analyze a little bit closer the structure of the XML. So we have by default it has this value, but because we modified it in the GUI, so it will have a different value now with the correct IP and so on. So the SSH target here is retrieve here, see here. So it will take these values in the properties. So the first custom step is we added these custom steps here. The first thing that we did is the copy runtime DLL. Okay, you can name it any name you want, and then you can put descriptions here, copying the DLL to target. And we need the SCP command to do that. And then this is where the DLL is from. So I've shown that this is the DLL should be copied. And then we put this DLL into the correct location, which is in the SSH there, which is the shortcut of the where we specify the target directory. So the DLL is now there. Next, we copy the exe. So the same principle. We copy the exe. The exe is somewhere in this location. Test. So it uses some variables, but they have their values later on. You will get used to it. This is the macro of the values. I mean, is the CPP test. This where lock is where just the path that we just seen a while ago, and the project name and concatenated with test.exe, and we also copy it remotely. After copying them remotely, we sysmode them, but there's really no need to do sysmode because sysmode is just for Linux Unix systems, but it doesn't hurt to have it here. Anyway, it has no effect. Then we run them. So notice that in this custom workflow, we use the ECP and the SSH tool in executing remotely. Even the deletion of the log file, we rely on SSH. But by default, there will be no SSH and SCP in your system, and you will encounter an error like cannot find program, something like that. So you will have to provide your own copy of those two binaries, the SCP and S. Fortunately, in my system, I have SSS and ECP because I installed the Windows subsystem for Linux. I believe there are many other ways to get the SCP and SSH command. For example, let me open a DOS prompt here. So if I type where SSH, where SCP, so I have this later on. I have this because I have okay because I enabled OpenSSH. So we need to copy this to copy this to the Parasoft executable bin in order for this bin to be found. And that executable bin is here. So this SCP and SSH were not here before. I copy it from here because these are external toolings that we need to do our thing, right? So we need to copy them here so that they can be found. We need to put them in the engine bin, these two XC. Okay. So because we put them into the engine bin, now this uh, custom step here, when we call SCP, will be operational because we now have an SCP command and so on. So these are just basic SSS SCP SCP command sets. Okay, there. So now let us try to run. But first, let us go to the remote machine first. Let's try to visit how it looks like. So this is how the remote machine looks like. The drive is still empty. And let me run the custom workflow now because this is now a custom XML workflow. We go to user define unit testing and you can see here remote run unit test. Click. So now it's creating the folder structure in the remote machine. It's copying the CPP test runtime 64.dll. It's copying the demo visual studio.exe and it's executing the test cases over there. Okay. And then the generated log file is gathered back locally and it will show us the coverage report here in a while. While that is running, we can try to visit over to the remote machine. Let me, it's not yet. Okay, let's try to analyze this error here. Go to output log, demo. Yep. Okay. Path here is as deleted. So the first problem that I encountered when trying to do this is the setting of the path and the format how the path is specified. Okay, let me. Mm-hmm. Yeah. So The thing here is we also need to create the directory over remotely, but we are not doing that here, right? See, so we need to mkdir, which I forgot to put. So let me copy over this custom step here because we did not create the folder structure of the remote machine, so it was not able to copy the stuff over there. And let me try to do that now. Copy. Before copying the DLL, we actually need to create the folder structure also. Okay, I will rename this ID as setup remote there. And then set up remote theirs. And then the command to set up is ssit target, and then just the familiar way of doing SSH. Okay, instead of running the executable, we now instead mkdir here. E to create subfolders. So in order for this mkdir command to be operational, you need to change the default shell of the remote machine to be bash. Otherwise, the default shell is DOS, and this command will not make sense. Okay. By the fact that mkdir -p is listed here as a command implies that it is being executed by a bash shell. So change the receiving shell of your Windows Open SSH to be of a bash terminal. Okay, let's copy this and let's put this into the rule. And let me add it here. The very first thing is to create the, I always press the enter key. Oh, here. Okay. Wait, let me just copy the entire XML and cut and paste everything. Review one more time. Let's indent properly. Oops. Okay. So now we have an extra command to set up the remote theirs where we SSH and mkdir here that will prepare the remote folder, then copying the DLL and the XC. Let us run them again. First, let's delete this output logs and run again our custom rule. User define. Okay. Now, while this is running, let us take a quick peek over to the remote machine. Okay, still running. And there. Take a while, but we now have the coverage result. If we go back to the remote machine, we can see the demo folder being created for us by the custom rule, and the exe and the DLL executed here. The logs have been auto-deleted by the custom workflow XML, so you cannot see it here. The logs copied back uh, here and then resulting to the code coverage here. So basically, that's the principle. Once you understand the principles outlined here, that you can control a lot of things via SSH command. So we can basically do a lot of stuff on top of this. But just try to familiarize yourself with the XML, and but basically that is just a thin layer of the icing. The fundamental core, which is the engine of all of this, is actually the SSH and the SCP tool sets. So we're just building on top of this. So we can now create any remote unit test using this principle outlined in this custom workflow. But just to take note that in this demo, we did not do cross compilation because the remote target and the source target have the same platform architecture. But at least through the principles described here, you now have the um, necessary apparatus to do any workflow that as you desire. Thank you.